my role here is, oops. There we go. I'm the chair of the Tropical Cyclone Panel of the Working Group on Tropical Meteorology Research of the WMO research, the World Weather Research Program of the World, all of that. The Working Group on Tropical Meteorology Research has two panels. I'm the chair of the Tropical Cyclone Panel. My colleague, Professor C.P. Chen, is the chair of the Monsoon Panel. So what I'm going to talk about today is that our working group on tropical meteorology research considers heavy rainfall events to be a prime objective, whether it's tropical cyclone related or whether it's monsoon related. And for this meeting, what we hope is that collaborative research and work will advance the science and forecasting of high societal impact events such as Morakot. So what I'm going to do is talk about WMO related things. Now some of you may think I'm a bit naive, not knowing something about the history of China and Taiwan and relationship to WMO. I am very aware of it, and I work very hard to try and include Taiwan researchers and forecasters in our activities. So I'm going to give thanks to Professor Lin-Chao Chen, Tang, sorry, I'm not even going to try that one, Harper Brown, who in pink. I'm going to talk about our activities, tropical cyclone-related precipitation from the second International Workshop on Tropical Cyclone Landfall Processes, which was held in Shanghai last October. We're the research side of WMO, but we cooperate with the regional tropical cyclone committees. For example, here in the Western North Pacific and Asia area, that would be the Typhoon Committee. So I'll use some PowerPoints from that. And I'm going to make my plug, as I always do, for the International Workshop on Tropical Cyclones #7 to be held in Reunion. So I will close by talking about some action items and research issues that I believe are important. I'm going to leave the Thorpex thing to Dr. Nagasawa. I'm going to make a pitch for the mesoscale model intercomparison and just say some words about what is the predictability of these. So most of my work, most of my PowerPoints come from somebody else. I'll try to explain them, but now that we just heard this description of Morakot, I can maybe talk. Oops, sorry about that. Let's see, forward. Okay, I'm used to the top one being advancing. Okay, so the impact session at the second International Workshop really focused on heavy precipitation events such as Morakot, and also tropical cyclone Nargis in the Bay of Bengal, where they think at least 133,000 people died in the flooding. And so, very high priority for WMO now is to work with these high impact rainfall events. And at that second International Workshop, we had forecasters from Taiwan included, Japan, China, 4 island countries, and we asked them to rank what is the most important things that you would need as forecasters from the research community to improve your forecast guidance. And in many cases, and these in particular, they ranked tropical cyclone precipitation amounts as being a high priority item, much more so than in the United States for various reasons, but one of them is something like that. Okay, the thing which is emphasized at this international workshop I'm talking about was the special characteristics, and we just heard it in the previous talk, of monsoon-influenced tropical cyclones creating these heavy precipitation events. And approximately 10 presentations were made about monsoon cooperation, and also influencing not just locally the precipitation associated with the typhoon, but also remote areas. So the key thing is persistent heavy rain even after landfall due to the large water vapor flux associated with monsoon circulation. So from Professor Chen's talk, we heard, okay, I'll get it yet. Professor Chen's talk, here's, boy. Professor Chen's talk, you know, I'm having difficulty seeing from this angle, but you know, what we're talking about is Billis is up here. This is the greatest economic impact on China ever. A persistent 3 to 4 day precipitation in 3 phases. Landfall, then a period in which the storm slowed down. Does this sound familiar? Storm slowed down, interacted with topography. Does that sound familiar? And then interacted with the cold front. And those 3 phases created this tremendous damage in China. So I can cover this quickly because it was just covered. The key thing here is that there was a lot of asymmetric structure, as just mentioned. Strong convection in the southern part of Morakot. You know, this is before it was landfalling on Taiwan, but what I want to emphasize here, and while it was in the Taiwan Strait, it was also beginning to have heavy rainfall in mainland China as well, and as indicated here. So the structure was not maybe what you would think of in the textbook typhoon structure, but this asymmetric convection led to the precipitation. And then this was a major event in mainland China as well. As I remember, 675 millimeters fell in certain areas of mainland China. And again, it's because of the slow movement, the asymmetric structure that led to this in mainland China as well. So this is a major thing, disorganized structure, and eventually, but because of the slow movement, led to a significant rainfall event in